Hey everyone, welcome back to HPLC Professionals, your go-to channel for all things high-performance liquid chromatography. If you're fascinated by how we separate compounds in a mixture, you're in the right place. Today, we're diving deep into the HPLC separation process and how it works. Let's get started. What is HPLC? So, what exactly is HPLC? High-performance liquid chromatography is a powerful analytical technique used to separate, identify, and quantify components in a mixture. It's widely used in pharmaceuticals, environmental testing, and food safety. But how does it actually work? Let's break it down. The basics of separation. At the heart of HPLC is the column. This is where the magic happens. The column is packed with stationary phase material that interacts differently with each compound in your sample. The goal? To achieve separation based on various properties like polarity, size, or charge. Next up, we have the mobile phase. This is the liquid that carries your sample through the column. The choice of mobile phase, whether it's a mix of water and solvents or something more specialized, can significantly impact the separation process. It's like choosing the right vehicle for your journey. The injection process. Now, let's talk about how the sample is introduced into the system. Using an injector, a precise volume of your sample is injected into the mobile phase. This is where things get interesting, as different compounds will start to interact with the stationary phase differently. Interaction and separation. As your sample travels through the column, compounds that interact more strongly with the stationary phase will take longer to elute, while those that interact less will move through faster. This difference in retention times is what leads to the separation of compounds, detection and analysis. Once the compounds exit the column, they pass through a detector. This is crucial for identifying and quantifying the separated components. Common detectors include UV, VIS, fluorescence, and mass spectrometry, each with its unique advantages depending on your analysis needs. Data interpretation. The final step is data interpretation. The detector generates a chromatogram, a visual representation of your separation. Each peak corresponds to a different compound, and by analyzing these peaks, you can determine the identity and concentration of each component in your sample. And there you have it, a clear and concise overview of how HPLC works and the separation process involved. If you found this video helpful, don't forget to hit that like button and subscribe for more HPLC insights. Have any questions? Drop them in the comments below, and we'll be sure to respond.